Hello everyone. This video is going to be a part 2 of the Mechanical Disciplinary Elective course reviews. So we are going to talk about three another disciplinary electives available at our university and what are the topics included in them and how are they useful for the study ahead. So for each of the course, we'll have major topics in the course, some study resources you should rely on, the evaluation scheme and how can you score good marks, and last will be the field of application. So the three courses included in this video are product design, finite element analysis, and the last one is mechanism and robotics. So let's start with the first course, which is product design. So this will be explained by my friend Nista, and over to her.
So product design is a course that walks you through the entire A to Z of how you would design a product. So like as you would design a product, the first question is what is the problem you are looking to solve with the product? So you would define the problem, gather information and generate the concept. Like suppose I'm looking to solve a problem regarding maybe a nail cutter that I have that is not like I want my nail cutter to be more neat such that it collects nails. So I'm defining the problem that the nail cutter is not collecting nails, and then I'm gathering information in the sense that I'm asking people whether this is something that they actually want, and then you're generating the concept. There are lots of mathematical factors and tables and trees that you're gonna have to know for this course. There are that is what is mostly going to be asked in the exams as well. So that those mathematical concepts are what are used to select your particular concept. It's going to mathematically weigh all possible options against each other. Once that is done, you're going to have to design your product in the sense that how to make it modular, how to select the materials, how to manufacture it such that it is the best possible way to manufacture, and how to price it such that against its competition it is possible to sell. All of this will be taught in the course from A to Z. Yep. So what happens in the course is that the professor is going to open up the slides. He is going to the slides basically have some pictures that he is going to use as a reference to explain everything to you. And there is barely any text in the lecture slides. And the textbook is useful to a certain extent, but not very much. So the only way you're going to be able to gain marks in this exam is by attending the lectures and actually paying attention to what he says, which can be slightly difficult because all the concepts are new. You would not have heard of these anywhere else. So it is important to pay attention. So for us, we had T1, T2, and T3, but considering that you all will have a mid-sem exam, we did also have assignments that were case studies of previous products or how to effectively problem solve. We had 3 surprise quizzes. We had lab assignments that were weekly submissions. Lab assignments were basically walking you through. You were given a product to design. You had to select your own product in a group of 2. You had to walk through the entire process of selecting, which includes serving the customers, trying to understand their needs, designing it, mathematically evaluating it, selecting materials, all of it. Then we had mid-sem, we had T1, T2, T3 and comprehensive exam, but you all will have mid-sem and comprehensive exam. So if you learn product design, the fields of applications would be product development, industrial process, product management, and design. If you're planning to become a product manager, these are some useful skills for you. A lot of these have a lot of overlap with product management skills, so that would definitely help you. And if you plan to go for a master's in design, this is a lot of what you would be learning in that as well.
Okay, thank you. Now we'll move on to the next course, which is Finite Element Analysis, generally abbreviated as FEM by my peers. So the purpose of this course will be, generally we have governing equations for any solid or any fluid flows, maybe static or dynamic situations, and those governing equations are, you have seen, were easy in case you have Newton's law, but it makes, or it becomes much complex when the material properties are complex or the boundary conditions, the force equations gets non-linear. So a specific method to solve those equations is developed, which is numerical technique, and one of the numerical technique is finite element analysis. There are other techniques also, such as finite volume analysis, finite difference method, etc. So this is one of the method to solve the governing equations numerically, and analytical solutions are not easily available. So this is the course which is there. So most of the course will have heavy parts on mathematics, and the major topics in the course are different types of problem to define, like 2D problem, 3D problem, elastic, non-elastic, bending, buckling, simple tensile force, compressive force, etc., twisting problems. Then we have different approaches to solve. So I just explained the different approaches, which is finite element method, finite difference method, residual method, energy methods, etc. Then the governing equations. So I explained that the governing equations arises from Newton's law, but whatever you have seen in 11th 12th were the most simplest part of them. Those becomes much more complex when you move further with non-linearities in your model. The non-linearities may be because of boundary conditions, maybe because of forces, because of some context, because of material properties, or the problem itself is non-linear, such as the buckling problem are generally non-linear. So the governing equations will have weak form and strong forms, differential form and integral form. So you will understand the different types of governing equations. Generally one can be derived from the other type, so they are interchangeable. Then the structures, which are frames and trusses, will be explained, and then we'll actually start with the simple 2D elastic problem solving, the method, so making grids and solving problems at each grid point, and then moving on to 3D, so stating a dynamic problem in three-dimensional uh, system can be solved. So the major resources to learn, generally professor doesn't use any slides over here. He'll use textbook itself. The theory part from the textbook is also useful, and practicing questions from textbook are also useful for exam. The MATLAB, if you have MATLAB programming known beforehand, then it will be advantageous. Even if you do not know, MATLAB programming is very much easy, and on the MATLAB on-ramp side or method side, the course on the beginner course for 3 hours is available. So you will have a general introduction and easily start with MATLAB programming, even if you do not know beforehand. Then the evaluation scheme. So uh, in the previous semester, there was literature survey and assignment, and Viva and project. Midsem and Compre were not taken. So all the stress was on project itself, but this may not be the case. So because the professor has changed from previous time to this time, that the previous professor has left our university, so what happens this time can be new, and he may introduce midsem and compre again, and decrease the percentage for project in the total evaluation. Then going to the fields of application. So finite element analysis is applicable in simulations, modeling, product design. If you want to do the automation of your simulation, then also you should have an understanding of finite element analysis. Then the software design part is also there. So that is a completely different field that may require your knowledge on programming and coding, where you will actually design the software or develop the softwares which will run the finite element analysis on them. So you know all the math part of it also, and the mechanical part of it also. Then they are also useful for designing manufacturing process, and a hell lot of different research are going on which will have the application of finite element analysis. So I think for all the research going on in mechanical, either there is CFD in application or there is FEM in application or FEA in application. So that's the two approaches generally taken into account generally when there are any research going on for mechanical departments. Then moving on to the next course, which is Mechanism and Robotics. So it's a heavy course again, and the first part will deal with design of mechanism. So it will have to synthesize the closed loop mechanisms and analysis of special mechanisms. And the second part will deal with manipulators, or what we commonly call as robots, and that are used to replace or supplement us like human beings in various work sites. So the major topics in this course will be the basics from KDM, kinematic and mechanisms part. Then we will have robot motion analysis, kinematic modeling, rigid body motion. So these errors regarding the rigid body motion are generally experienced in numerical analysis softwares because there are numerical singularities occurring because of rigid body motion. So that's one part of it. Then we have differential motion, control strategies, robot trajectory and programming, machine vision, and sensors. The major resources will be, again, if you have some background of MATLAB programming, then it is advantageous to you. Professor will definitely share material such as slides, and that will be very much useful. The theory part can be also understood from textbook, but whatever he teaches in class is more than enough. He is an expert. Earlier it was taken by Singru sir, so he is very good at the robots and mechanism development, and he's been in this topic since maybe 25 to 30 years. So he's well connected in industry, so he has a very good idea of what the things are what things are going on in research and in commercial sector. For questions, mostly the questions will be what he has shown in during the class, so that's the class will be helpful. Maybe the calculation parts are very high, so MATLAB is definitely going to be helpful, and obviously you should be very thorough with using your calculator. There are a lot of calculations. They are not tricky, they are not hard, but they are time consuming, so you should be very quick with your calculator. The evaluation scheme will be there will be some assignment or some project. The attendance may be taking maybe 5% of the total, but they may skip attendance. And there will be midsem and compre, so all will have almost the numerical questions and maybe designing of robot systems on your own given some problem. And if there are numerical problems, the question will be different for all. Like the basic idea of the question will be same, the theme, but the numbers will obviously be different for all of you. So avoid copying during the exams. And the field of application, so you think of anything around yourself, there are robots, there are mechanisms involved, such as in manufacturing industry, automobiles, everywhere, wherever you can think of, everywhere the robots are involved. So there are lot of applications of this course, and you will get a very foundation for the masters in mechanisms and robotics. So that's the end of it. Thank you. If you have any queries, please ask. The handouts for these three courses are available in the description. Thank you.